of the things I used to work on, and we still do, is the Kepler Space Telescope. So this was one of NASA's telescopes that I helped work on. And so it was most famous for finding planets around other stars, monitoring and finding what we call exoplanets. One of the interesting things that happened was, interesting, maybe it's not the right word. So in space, space is 3 dimensions, side to side, back and forth, up and down. So we have these big pendulums or gyroscopes that kind of help us steer in each direction. Now, this telescope was built with 4, so we have 3 directions plus kind of a spare. Well, 2 of them broke, which meant that you can only point in 2 directions, which isn't very useful in space. And so a lot of us came together to figure out what could we do to fix kind of this telescope without being able to send new parts. And then we realized that if we tilt the telescope and point it towards the sun, we can actually use wind and light from the sun to blow on it like a sail. So just as a sailboat goes through water, we use light from the sun to blow on it through space. That gave us our one direction, and use the remaining wheels for the other 2 to get this mission to work. And because of this, we changed it a bit, and it spent half the time looking for exploding stars, what I work on. And the cool thing is, because Kepler took an image every 30 minutes, so it took an image every 30 minutes, we're actually able to see stars like the minute they explode, literally see the actual star blowing up in real time. And that has been one of the coolest things I've worked on. And this is kind of the essence of science. Sometimes you have theories that you need to confirm, and it's all about finding different ways. And then we said, hey, well, you know, one of the tricks always is we don't know when the star is going to explode. We don't know when or where. You know, we could be waiting millions of years. So we said, hey, if we just kind of stack the deck, if we just look at thousands upon thousands of galaxies every 30 minutes, we're bound to catch a couple of them. So let's stack the odds in our favor. And that's exactly what happened. And when we saw that star explode, and what happens, it actually produces a shock wave. So if you imagine like a nuclear bomb, you get the shock wave and then the nasty bit behind it. We saw the shock wave ripping the star apart and then the star igniting. And it was cool because, again, it was a theory that's been around since, I mean, originally actually since the 1920s with Subrahmanyan Chandrasekhar when he won the Nobel Prize, and then in the 60s and 70s, and then being able to go out and see how this happens was really amazing.